Hi. Oh my goodness, this is way too loud. Let me see if I can. Can we adjust the volume just a little bit? Is it a little too loud? Okay, we'll go for it. All right. So first of all, thank you very much for attending this session. I'll talk to you a little bit about the newly minted Java E8 release and a little bit about what is going on in the Java E8 Java ecosystem in general. And I think there's a lot of interesting stuff going on. Hopefully, I'll get to share a little bit of that with you. Can we move to the slide? Thank you very much. Okay, fair enough. So I've tried to weave this particular session as a story. It's a story about a community, and to some degree, for me personally, it is a personal. This is a story that has a personal dimension. As you know, Java E is not a spring chicken. It's a platform that's been around for quite a while. And in fact, one of the more interesting sessions that I saw at Java 1 is something called postmodern Java E. And the basic theme of this talk is that you have so many technologies moving so fast in our ecosystem that technologies come and go. But the reality is that there's some things that almost never change. They stay relatively static in our industry. And the two main things that have stayed static for Java developers in particular, that form the foundation of everything that we do, is Java SE and Java EE. And that's basically the story, the basic story of structure and stability that Java EE brings us. So this story starts quite a few years ago with J2EE. J2EE, basically what that J2EE did was establish the foundation of what server-side Java should be. Regardless of what you may think of J2EE, the reality is J2EE succeeded in its mission. It created a foundation strong enough for us to now that we can still talk about server-side Java in meaningful ways, despite all of these changes that have occurred. Now, the problem was, as we know, J2E was not a perfect technology. What happened in the J2E timeframe, as we all know, is that we saw the ecosystem grow enough to accommodate things beyond just the standard APIs, so things like Spring and Hibernate. In Java EE5, what happened was the beginning of an interesting symbiosis between the standard and what is beyond the standard. So what Java EE5 is really all about, establishing that relationship. Establishing the relationship whereby Java EE innovates, and those innovations go over into the realm of the ecosystem, but Java EE also takes from the ecosystem as well. In fact, Java EE5 is a perfect example of that. So one of the principal ideas that were adopted from the ecosystem were things like posture-driven development. So the idea that you can develop your components without having hard dependencies on your fundamental platform, so without having to extend interfaces or implement subclasses. However, Java EE5 also added bona fide innovations on its own right, two fundamental innovations. Number one is the idea of using annotations as metadata, as opposed to using XML as metadata. And that was so successful that it still resonates with the rest of the ecosystem. So if you look at something like JUnit, for example, JUnit is still taking those ideas and adopting those ideas that were established about 8 or 10 years ago in Java EE5. Similarly, convention over configuration. A lot of other platforms talk about convention over configuration. The reality is, in the Java EE environment for us, we've enjoyed this idea of convention over configuration for a very, very long time. But what Java EE was lacking, EE5 was lacking, is essentially feature completeness. In particular, when I would develop Java EE5 applications from my transition years from J to EE, what happened was I immediately tried to use Seam. And the reason for that was it was lacking a basic fundamental capability in terms of generic dependency injection. So Java EE5 had a notion of dependency injection, but not a generic one. So that's what things like CDI added in the platform. And as of Java EE6, we really saw a fundamental shift, right? So whereas we saw a growth of the platform in the J2E5 era, that the platform was essentially in crisis in the Java EE5 timeframe. But in the Java EE6, we really began to see the community revive again around Java EE finally. Okay? And in Java EE 7 really is about solidification. It is about looking in the future and seeing what can we do to make the platform feature complete for a good number of years. So you saw innovations like WebSocket, for example, and you saw JSON being introduced as a first-class citizen of the platform, as well as other innovations like JMS 2.0. Which then brings us to Java EE 8. So what I would say is Java EE 8 is essentially a continuation of Java EE 7 and making the platform even more feature complete, perhaps going into 5 years in the future. So this is also an important slide that I feel I must present. There's a lot of negativity and naysaying around Java EE, and it's nothing new. For those of us who believe in the platform, we've seen this sort of negativity and naysaying for a very long time. But I think it's important to put all of that stuff in a objective context. And one of the more objective contexts that you can put into is, what do developers actually say when they are asked the question, do you use Java EE or not? Okay? And the reality is that in survey after survey, developers are indeed saying that Java EE is a technology that they adopt. Whether they adopt it wholesale as all of the APIs in the platform or parts of these APIs, Java EE is still fundamentally important to all of us. If you want to see a little bit of this, we actually have done, we've compiled a few of these results yourself. And you can take a look at what I mean when I say this. The other thing that really energizes me and makes me believe in the Java EE platform is the ecosystem itself. There's just a large number of companies, large number of individuals that continue to invest in Java EE. These are all the way from large implementations from large companies to a bunch of small open source projects that all believe in this platform and contribute to the growth of this platform. And actually, one of the most interesting aspects of this ecosystem today is something called microprofile.io. If you haven't heard of it before, I encourage you to listen to the talk after mine that Ivor Grimstad is going to present to you. And it's really all about how you take the Java EE ecosystem and move it forward, and you build on top of it in an organic fashion. So now, I think we can set the stage of talking about the story of Java EE 8. And the story of Java EE 8 has ups and downs, and it does start with an up. It is, in a sense, up because Java EE 8 is very, very unique in the way that it was developed. Normally, when you talk about Java SE or Java EE, the scopes of these technologies are driven by vendors behind closed doors. So if you talk about, let's say, the next version of .NET, developers don't really have a say on what goes into the next version of .NET. In fact, the same can be said of Java SE as well. Largely, the scope of these technologies are defined by specific companies. In case of Java SE, frankly, more or less Oracle. In case of something like .NET, frankly, more or less Microsoft. In case of Spring, more or less Pivotal. Java EE 8 is one of the very first times that a major technology like this, the scope of it, the initial scope of the technology was defined by the community. How was that done? That was done through an open survey. So what happened was that we at Oracle, and I was at Oracle at the time, we came up with the initial ideas on what we wanted to do for Java EE 8. But instead of just determining and telling the community, okay, this is what we're going to do, we asked the community, hey, community, what do you want us to be working on? Okay? And that survey was actually participated on by almost 4,000 input points. We had almost 4,000 input points globally to determine what Java EE 8 should look like. And that is still a very important data point. If you want to find out what that survey results said, that's within that link right there. Okay, so these were the results of these surveys. And this is initially what determined how Java EE 8 looked like in the end. Okay, so this was the initial scope of Java EE 8. There are several key themes here. First and foremost is web standards alignment. So this work started in Java EE 7, but it continued with Java EE 8. So some of these important things are alignment with HTTP 2.0, alignment with service sent events, First, better support for JSON, as well as an action-oriented web framework. And I'll talk about all of these things in detail, obviously, in the main part of this talk. The other important thing that happened in Java 8 is better alignment with CDI. So CDI was an important technology on its own right, introduced in Java EE 6. But what happened since Java EE 6 was that CDI went through incremental releases. So we had a 1.1 and 1.2 release in the Java EE 7 timeframe. But with Java EE 8, you now have one major release of CDI, namely CDI 2.0. And to go along with that, what Oracle also initially proposed to do is better align the entire platform with CDI. So what this means is basically taking out all of the existing EJB features and bringing them out into CDI-based services, so you can gradually deprecate the EJB functionality altogether. Similarly, same thing for JSF. Okay, JSF has its own component model, and that component model, by and large, overlapped with what CDI provided. So one of the things that we could have, we aimed to do in Java 8 was basically deprecate the JSF managed bean model altogether. And similarly, there's other enterprise features that the community long awaited for and wanted. So some of these things are security, JCache, further revision of JMS. And obviously, a lot of those are mean-specific feature enhancements that I'll talk about in a second. And finally, Java SE alignment. Okay, so one of the fundamental features of Java EE is that it always aligns with what Java SE provides. So one of the big examples of this is, like I said, annotations. Annotations were introduced in Java SE 5, and Java EE 5 was the first major technology to adopt and show how annotations can be used, okay, in a big way in annotations. So similarly, there was alignment work that needed to be done for Java SE 8 as well. Java SE 8 was a major release, as you know. There were a number of features that were added in Java SE 8, and the platform as a whole needed to align with those features. So now let's talk about a slightly deeper dive into what exactly is in Java 8. So the best place to start with this is in Servlet 4. So Servlet 4 is really all about adding support for HTTP 2.0. So before I talk too much about this, let me ask a simple question. How many of you know what HTTP 2.0 is? Okay, all right. I'll explain to you what HTTP 2.0 is. HTTP 2.0 took 15 years to make. Okay, it was a long-running standard. The last time we had a revision of this was in HTTP 1.1 era. In the HTTP 1.1 era, the web looked very different than it does today. In HTTP 1.1 era, the web looked very much like a Wikipedia page. Okay, so you would click on a link, you would get a bunch of text, it would be formatted, it would have some hyperlinks in it, perhaps it may have one or two images in it. But basically, the idea is simple rendering of pages. So the request response model of HTTP 1.1 and 1.0 made a lot of sense. So in HTTP 1.1, the basic idea is that you make a URL request, and within that URL request, you receive essentially 1 unit of output. Okay, and that makes a lot of sense if you have a simple web page like, for example, a Wikipedia page. The problem is that the web of today does not look like that. In fact, Google did a little bit of statistics gathering, and the reality is that an average website, let's say for a corporate homepage like CNN.com or BBC or eBay or Amazon, the reality is each of those pages with a single GET request to render that page, you actually wind up making 41, on average about 40 different HTTP resources. Okay, so that old HTTP model breaks down in this world, because what happens is now you are making 41 different connection requests to render a single page, which is extremely wasteful. Okay, so HTTP 2.0 is really all about solving that problem, solving that paradigm mismatch. And how do you do that? The fundamental way you do that really is by using a technique called multiplexing, which means using a single connection and keeping that connection open for the live duration of a web page rendering. So what that means is now you can essentially transport 41 different resources over a single connection. That's the big fundamental change in HTTP 2.0. On average, what this means is that if you move an existing page from HTTP 1.1 to HTTP 2.0, you can expect on average about 8 to 10 times performance improvement, or at least perceived performance improvement. This is a very, very big deal. And of course, that's not the only thing that happened in HTTP 2.0. There was a bunch of other changes that also took place. You can see some of those. So these are things like stream prioritization, server push, binary framing, and header compression. Okay. But the great news for all of us in the Java EE world is that all of these changes are basically transparent to you. It does not mean very many API changes at the HTTP level. So the Servlet API, by and large, remains intact. All that the Servlet 4 API does is that it tells the underlying Servlet engine, you must now support HTTP 2 under the hood. Okay? So this is a very, very big deal. Perhaps this is the most important feature that is in Java 8, if you were to just name one feature. So in Java 7, we introduced a JSON processing API called JSON P 1.2. Okay, and this was our first step towards making JSON a first-class citizen of the platform. So the idea here is that JSON should be very much like a native serialization protocol. So you should be able to think of JSON just like you do perhaps XML in the platform or Java serialization in the platform. So it's just something that is there. You don't need to think about it. You can just use it and count and depend on it just working. That is the fundamental idea behind JSON B and JSON P. So the idea here is that the capability is baked into the platform. It is so easy to use that it is almost transparent to you. And the way this is really empowered is through this JSON binding API that was added in Java 8. Okay? So I'll show you a little bit of how that looks like. Quite literally speaking, your API call could look something very much like this. So let's say you have an existing entity object. It is just a POJO. You don't need to annotate anything at all. That's the basic idea. Everything should just work by default. And you go ahead and create your POJO the way you would. And as soon as you pass it through the JSON binding API, it will basically transparently, by default, create a sensible default JSON representation for you. And this is especially helpful if you are, for example, returning a JSON payload from a JAX-RS endpoint. All you really have to do is, okay, say that I am producing type of JSON, and because JSON B is now part of the platform, it will just work magically. Now, besides adding JSON binding API, there was also some changes made to JSON P, the JSON P API as well. Now, as a reminder, the JSON P API is basically a lower level API, whereas the binding API is more like JAX B. You add annotations to make binding happen, or binding for the most part happens automatically. Here you have to write programmatic API. You have to write some code to actually do the JSON serialization and deserialization. By and large, in JSON P 1.0, it's a mature API. You didn't need to do a whole lot to make it feature complete. What JSON P 1.1 is actually about is basically keeping up to date with the JSON standards themselves. By the way, if you didn't know, JSON itself is actually a W3C standard. Okay, so the two principal standards that we needed to adopt to in Java EE 8 was JSON pointer and JSON patch. Okay, I'll tell you a little bit about JSON pointer and JSON patch. And also there were some minor improvements to better align with Java SE8, in particular Java SE8 streams. So this is an example of JSON pointer. For those of you who have seen something like XPath before, this is really much like XPath for JSON. So the idea here is that you would specify a URN-like syntax to navigate a JSON content. So for example, /0 phones mobile means go to the first element, go to the phones array, and pick out the mobile element of it. Okay, so it's kind of like a selector for those of you who are more familiar with perhaps the JavaScript world. And what is being done now is basically in the JSON P API, you don't have to, you can natively use this JSON pointer API just like that. All right. So you don't have to navigate the JSON manually yourself anymore. JSON patch is even more interesting. So what JSON patch actually is that it is a way of saying, here's my source JSON object. I want to make a modification to this source JSON object. So I am essentially performing incremental CRUD operations. So operations like perhaps add, replace, remove, copy, or test, okay, per a element in your JSON. So what you can do now is essentially express that CRUD operation in a JSON document on its own. All right, so the JSON patch request itself can look something like this. So I have a couple of examples here. So we have a replace operation and a remove operation. In the replace operation, we are specifying a JSON path and saying, okay, whatever is in this JSON path, please replace it with this new value. Similarly, in the next one, we're saying, please remove an element in the JSON path. And in this case, we're saying, okay, please remove the first element. So now, again, you can have a native API built into JSON P 1.1 that performs these operations for you. And in fact, this uses the builder API under the hood. So you can actually write quite nice syntactic verbiage to perform these JSON patch operations using the JSON P 1.1 API. The next feature that I want to talk to you about is something called server-sent events. How many people here have heard of server-sent events? Okay, a few. All right, so I'll explain that as well. Server-sent events was something that was added as part of the HTML5 body of standards. So similar to WebSocket, right? So things like WebSocket were added, and as well as some of the custom markup for HTML5 as well as server-sent events. What is this about? So there are two extremes when it comes to HTTP interactions. There's the vanilla HTTP request. Okay, the vanilla HTTP request is request response. So you make a single request and the server makes a single response to you. And you have to do that in a repeated fashion. WebSocket is the exact opposite. So WebSocket is a lot like basically a raw TCP connection. You can have essentially multi-dimensional communication, completely asynchronous and completely bidirectional. So once you establish a WebSocket connection through HTTP to a server, either the server or the client can then communicate with each other in a completely asynchronous fashion. So a good example of that is, for example, a chat application. So if you have a chat server, the chat server will communicate asynchronously and bidirectionally with the client. SSE is something in the middle. So the basic idea of SSE is that you still have client-initiated connections. Okay, so the client will say, hey, I am ready to do something. But the server, in case of SSE, instead of returning a single response, will actually return multiple responses over a period of time. So you can think of this as a stream. All right. So a good example of this is things like stock ticker applications. So let's say you're interested in monitoring a stock. You connect up to the server-sent event endpoint, and over a period of time, the server will send you updates of that stock. Under the hood, this is actually nothing much more than just vanilla HTTP with a specific content type. Okay, so the API looks something like this. So let's suppose we're going ahead and implementing that stock ticker path. So most of the classes will actually look very much like your vanilla JAX-RS endpoint. So in this case, we're publishing our HTTP path as tickers. Okay, and you make a GET request to get the codes. But what happens in this case is notice the return type. So normally, if you're making a GET request, what you will get as a response of that GET request is simply the payload. Right? This is the payload I'm returning you. But notice what it is in this case. It's a void. All right. So what is happening here? So instead of returning just a single response, what you're doing again is returning multiple responses. And the way you do that is basically using two different APIs. They're called SSC, event sync, and SSC. Okay, as you can see in my example, you basically take the sink. The sink is a pipe for the event, and the SSC object is a convenience utility so that you can create these events. So, for example, I'm creating a new event and I'm passing in the Pojo stock code. And basically, the runtime is creating and translating all of these things for me and sending it back to the client in text event stream format. JavaE security is actually one of the most important, fundamentally important APIs that was added in JavaE 8, especially for people that are heavily dependent on the JavaE platform. But this requires a little bit of explanation. So if I say that JavaE security is one of the biggest things in JavaE 8, well, you'll be wondering, well, what happened from J2E to JavaE 7? The reality, though, is that we actually have had a very good solution for security in JavaE for a very long time. The problem is, this solution is very different from all of the other solutions out there. Prior to JavaE 8, the way you secure a JavaE application is that you actually do not specify anything security related in the application itself. All the application really does is that it forms a signature, a contract between the container and the application. So the application essentially says, I am a secure application. Please secure me against a logical domain and use an authentication method like, let's say, basic authentication or digest-based authentication, and that's it. What actually happened is that this contract is realized by the container. So typically, the container will have a console, and within that console, you'll have a nice GUI-based solution where you can do point and click and say, and fill in the rest of the details. And say, okay, I'm securing this application against a database, or I'm securing this application against LDAP. And these are the roles that map into the roles that are meaningful to my application. I actually think that is the right security solution for most enterprise applications. You, as an application developer, shouldn't be concerned with these things. You should just write your application in an agnostic way and define your contract and let the administrator or somebody else that needs to deal with these security details deal with these things, not you as a developer. However, there's a couple of different problems with this approach. One problem is that most other platforms do not have this capability. Most other platforms, if you look at them, for example, Rails or Node, okay, they don't have a GUI, they don't have an admin console. The way they secure their applications is that they have embedded security. They embed all of that security information within their application, and the developers write this security code. So what this means is that those developers, when they're looking at JavaE, they're saying, okay, you know, what is going on here? Where's my handwritten security code? The other practical problem that JavaE security creates is that because the security is so dependent on the container, it means that once you port a JavaE application from one application container to another, you have to port over all of those security capabilities because the admin capabilities are slightly different from one container to the other. So the basic goal of JavaE security is solving those problems. Okay, then how does it actually go about solving those problems? The first thing we did is actually introduce a very simple way of saying, how do you secure an application? So literally, all you have to do to secure a JavaE application right now is specify a single annotation just like this. Okay? All you say is, okay, I want to secure, this is a secure application. I'm going to secure this application against a database. Or I'm going to secure this application against LDAP. And you just specify this one annotation and then you are done. Okay? It is embedded within the application now. It is no longer within in and out external GUI, and it is just as simple as that. So this makes JavaE actually one of the simplest platforms to secure. Now, let's assume for a second that you do not you secure your application using a well-known method. You don't use a database, or your database looks very different than what the annotation-based API expects. And you don't use LDAP, or you don't use embedded security. You have some other custom security mechanism. What do you do then? So in order to solve that problem, what Java E8 introduced is the idea of creating a custom identity store. So this is really nothing much more than a POJO. It can be any CDI managed object. All you need to do is essentially implement the identity store interface, and it has just one method that you need to implement called validate. It takes the credentials as an argument. Credentials are generally just a username, password, or in case of digest-based authentication, it may be the actual digest token. And then you do whatever it is that you need to do. You can write your own custom validation logic. In my example, for example, I'm injecting a custom homemade user service. I'm doing my validation here, and then I'll return back a credential validation result. Largely just success or failure, and in case of failure, some error messages to say, okay, why did this authentication fail? In addition to that, what JavaE also did is make the security context very uniform. So JavaE had a security context, but it was fragmented. Okay, so EJB had a security context API. The servlets had a security context API. They looked largely very similar, but they're different APIs. So now you actually have one uniform security context API. It's called security context, thankfully. All you need to do, let's say in case you're writing your own custom secure application and not using the JavaE roles allowed annotation, well, you can do something like this. You can write an interceptor, you can inject the security context, and the security context will have convenience method like getColorPrincipal or isColorEnroll that will allow you to write highly custom code, all right, and do any kind of security manipulation under the hood that you want to write by yourself. One other very interesting idea that we talked about in the Java 8 timeframe is this concept of essentially blending together declarative and programmatic ways of securing applications. So the normal way of securing Java applications and doing authorization is still the roles allowed annotation. If you want to go to the other extreme, you can write your own handwritten interceptor, just like I showed you before. This idea here is to do something in the middle. And the way you do that is by introducing EL, expression language annotations, within this isAuthorize annotation and having these custom methods to do custom utility methods to do fairly rich authentication and authorization. CDI2, as I mentioned, is one of the other key things that was done in Java E8. The principal themes here is adding formal support for Java SE. So basically a Java SE Bootstrap API. This used to be actually available in almost all of the CDI containers already in a non-standard fashion. So now that is actually standardized. The other important thing that was added is asynchronous events. I'll show you an example of that in a second. This goes along with actually better and better asynchronous processing support across the entire platform. And then finally, you also have some simplifications in the SPI, as well as some alignment with Java SE8. So I won't, in the interest of time, I don't really have a lot of time to go into a lot of these in detail, but I'll show you a simple example. This is how CDI asynchronous events look like. CDI has this, if you haven't seen this before, CDI has a very nice type-safe API of doing events. Okay, so it's a simple API where you inject a type of event and you specify what the payload is. So let's say my event payload is cargo. All right, and then in order to fire this event, you simply say event.fire. And it fires your event for you, and you can have these observer methods that will consume these events very, very easily. It's just a POJO, and then you specify the observes annotation, and the payload matches whatever the event type is. So in my case, the cargo is basically the event type. So in Java E6, this was all done synchronously, meaning that when you fired off an event, that event and the observer belonged in the same thread. Okay. Now in CDI 2.0 and Java E8, if you want, you can actually make it completely asynchronous. So if you call fire async, in case of simply fire, this will actually now fire off on a separate thread, and you will immediately get a return back from the fire async, and you'll receive those notifications also on a separate thread using the observes async annotation. This is actually another one of my most favorite features in proposed features in Java 8. It is JMS 2.1. The principal idea here is to, again, decouple from the EJB annotation-based API. There's nothing in particular message-driven means. So this, the idea here was to essentially create a much more generic and much more powerful version of message-driven beans. Okay, whereas you would have been able to do things like not just receive the message object, but in the underlying payload of the JMS message. So for example, in this case, let's say handling registration attempt. So you no longer need to have a listener object that must only receive a JMS message object as parameter. In addition to that, you can do other interesting things. For example, you can receive messages in batches, okay, batches of 10, let's say, instead of receiving a single JMS message every time. You can specify retries, retry delays, dead letter queues, all of these other things as well. So much more powerful and much more fluent version of message-driven means. And notice that there is no EJB annotation at the top as well. It can just be a normal CDI bean. Any CDI bean can consume a JMS message. That was the fundamental idea here. The MVC API is also a very, very important one. For the longest time, obviously we had just one presentation tier framework in Java EE, namely JSF. And JSF has a strong showing. JSF has a very, very fundamentally strong ecosystem still built on it. It's a very old API, and yet it's still a very well-used API. The problem with that, though, is that JSF doesn't always fit well in scenarios where you need direct access to the underlying HTTP object, okay? Because JSF creates a lot of abstractions to get you a much more cleaner API that almost looks like a desktop application. You don't HTTP almost vanishes. In order to solve this problem and get you access to the lower level APIs, you actually need something that looks more like an action-based web framework. We actually put this question in the initial Java 8 survey, and surprisingly, a lot of people actually wanted such an API. Okay, we weren't expecting that, but people wanted this API. So we added this API initially to the initial scope of Java 8. The nice thing is, it's actually not very difficult to do, because a lot of the work is already done. You already have a lot of the model work done in CDI, bean validation, and JPA. You have a view layer technology, namely facelets on JSP, and you can make it extensible. So you can add support for things like time leaf and what have you, other markup languages. The majority of the work is actually the controller level. Okay, and in fact, a lot of that work is also done in JAX-RS. So you really need a very, very small number of APIs. For a basic page, you actually just need one additional annotation to make MVC work, namely the view annotation. Okay, so what you have here is that you're essentially taking an existing JAX-RS endpoint and mapping it to an MVC object, just by specifying a view to say, okay, when this get method renders, please take the results of this HTTP get call and populate it into this view. So relatively very clean, straightforward API. Finally, adopting Java SE8 is a very, very important portion of Java 8 as well. So as you know, Java SE8 included a number of important features. Some of these important features were things like repeatable annotations, the new datetime API, completable features, and the like. The good news is a lot of these APIs were by and large forward compatible, which means that a lot of the Java SE8 features you can basically just lift and shift and use in Java E7 type applications. So this applies to things like the datetime API and completable features. However, there are some cases where you needed to make specific changes in the Java EE API to better support these features. Okay, so some example of these are for repeatable annotations, things like JPA, JMS, and Java Mail. For the datetime API, JSF, JPA, and bean validation. And for completable features, things like JAX-RS, EJB, and WebSocket. So let's take a look at some specific examples of what this means. For example, in repeatable annotations, in Java E7, or more specifically in Java SE7, in order to repeat an annotation, let's say the named query annotations, you couldn't do that because Java SE would not allow you to do it. So the trick that was used was basically to create these wrapper annotations, okay, to be able to repeat these annotations over and over again. In Java SE8, you no longer need to do that. So all of the places where you can have this pattern, now you can replace it with the pattern below, which means you can directly repeat annotations. The datetime API is also an important one. So let's imagine for a second that you're dealing with existing Java E7 code. In Java E7 code, if you put in this bit of code, this code will not work because the JPA version in Java E7 will not recognize what this instant object is, right? It will simply not be able to translate it. However, with Java E8, now you can do that. You can natively have all of the Java E datetime API classes, and that will automatically be translated for you. The completable futures API is also a very, very interesting one as well. So in this particular case, there's various places where Java E uses asynchronous capabilities. Okay, so in all of those cases, instead of just using the Java util future class, you can now use the completable future and completion stage example as well. There are some other changes. Obviously, in the interest of time, I won't be able to cover them. So these are things like native WebSocket integration in JSF, CDI integration, much more bean validation constraints. So almost 10 or 15 bean validation constraints were added. So some key examples are something like email and not empty. The example I showed you in SSE is a single request and response. You can also do broadcast of SSE objects. So you can broadcast an SSE event to multiple clients, not just one client. CDI event ordering is another one, and stream support in JPA is another one. So a bunch of a lot of features that were added, that were slated to be added in Java 8. Now, the problem that we saw as important, hopefully as you figured out the Java 8 release was, something very troubling happened in the 2006 timeframe. What we saw in the community, for those of us that take a look at Java E, is Oracle suddenly stopped working on Java E8 APIs for almost 6 months. All right. So what we did was, in order to solve this problem, we actually created an organization called the Java E Guardians to raise the awareness of this issue and to tell Oracle, please start working on Java 8 again. This stuff matters. So finally, Oracle listened to us, and they put out another survey to revalidate what should be put in Java 8. The good news here is that there weren't very many changes. Okay, what we actually found out in the survey is that there's a bunch of stuff that Oracle proposed to add. But the reality was the community wasn't so interested in standardizing those features. They really wanted the features that were already in scope for Java 8. So by and large, I would say almost 80 to 90% of what we asked for in the initial scope of Java 8 was actually delivered. The big exceptions were the action-oriented web framework. Oracle didn't want to work on this. But instead of just not doing the work, they actually gave this work to Ivar, who's going to be speaking to you next. And he is moving this work forward, and hopefully the MVC API will also be added as an option for Java 8 developers very, very soon. The other thing that unfortunately wasn't done is the work to fully replace EJB. Okay, so only a small amount of that work was done, and so we still have EJB as a competitor to sort of the CDI programming model. The other thing that Oracle dropped was JCAS and JMS. But again, taking a look at the big picture, it's still a very solid release. Majority of the things that I talked about were actually delivered in the last Java 1 timeframe. So now we actually do have an official final release of Java 8, and vendors can begin to implement this themselves. And in fact, you can try it out. Glassfish 5.0 is now available. You can not just read about these features, you can actually try these features out and begin implementing these features, and you can really see how much more powerful Java E applications now are. The other very important thing, and in fact I will say that this is the most important slide that I have today for you, is that Java EE is no longer an Oracle-specific technology. Okay, Java EE is now moving to an open source foundation, fully open source. Anyone that wants to contribute to Java EE can do so as an equal partner. All right, Oracle is essentially giving up control of Java EE. Never before has something like this happened in the Java ecosystem. That such a big part of the Java platform is now open to the community. So it is being started as something called Eclipse Enterprise for Java, or EE4J. This is an initiative that is being started right now. Hopefully next year I'll be able to come tell you as to what exactly is happening and what the fundamental progress is in the EE4J initiative. But the time to get involved is now. If you want to get involved in the future and you want to redefine the future of how server-side Java should look like, this is the place you need to be. Okay, so those are the two links for you. Please consider getting involved now. So I want to finish this talk talking a little bit about what is next. What does the future look like? What are the things that could be included in the future of Java EE? And the most fundamentally important aspect of this is all of these things were put in the renewed Java 8 survey. The reality is just about 30 to 40% of developers that voted on that survey were interested in these features. So what that means is that Java EE 8 is a very fundamentally solid platform that'll probably serve our interests for quite a while. However, these are the things, these are the next logical things that we could be working on in Java EE. And here's the good news. A lot of this work is already done. Okay? It is already done through the microprofile initiative. So what this means to you is that you can expect all of these other features into serious consideration of Java 8 very, very soon through the EE4J initiative. Okay? So this is the time for you to get involved and think about what are of these features would you actually like being standardized? And what of these features do you not want standardized and you just want to keep it as part of the microprofile initiative as a non-standard solution? Okay? And again, the way you make your voice heard is through that EE4J initiative. So again, fundamentally, Java EE 8 is still important. Okay? Anyone that tells you otherwise, rethink that. Okay? Java EE 8 is a very, very solid release. Hopefully I've shown you all of the features that were actually added in Java EE 8 and why it's important to you. So please evaluate it. Even if you don't want to use the entire platform, evaluate the parts of the API that's valuable to you. And finally, please get involved. Okay, there's never been a better time to get involved in the future of Java EE. You can do that through the EE4J initiative. You can do that through the microprofile initiative. If there's one thing you do out of this talk, please consider doing that. Thank you very much. That's all I have. The slides are available out there. I hope this is useful. So I have about 5 more minutes. Can I take some Q&A? Do you mind? Yes, sir. The question is, what is my favorite container? I don't have a favorite container. I think all of the Java EE containers have strengths and weaknesses. I'll tell you some of the ones that I have used. I like Wildfly. It's open source. It's extremely fast loading. It's extremely modular. I also like Tom EE. It's extremely lightweight. I like Glassfish because I've used Glassfish forever. And the Pyara guys do a fantastic job in developing Pyara. And I also like Open Liberty and WebSphere Liberty because it's a very, very polished, very, very professional, and very, very strong commercial offering from IBM.
And what do you think about Wildfly Swarm?
Wildfly Swarm is a very promising project. Wildfly Swarm is actually what is implementing the microprofile standard at this moment. I think it will be a very fundamentally important complement to the Wildfly application server. So you now have a choice. You can use either the Wildfly, the application server, or you can use Wildfly Swarm, the FatJar solution. Is Wildfly Swarm production ready? Yes. So I have used it on a couple of demo projects. I know a couple of people that actually are using Wildfly Swarm in production.
Thank you very much.
Yes, sir.
What is a better way to join the community, as a company or as an individual developer? Can you explain?
I'm sorry?
What is the better way to join the community, as a company or as an individual developer?
I say individual. I've contributed to JavaE as an individual for almost 10 years now. If you want to join as a company, your company will support you, all the more power to you. But in the end, you will have the most flexibility and you'll be able to do the most as an individual. Yes, sir.
So what can be the main advantages for old enterprise projects? So currently in production, we are still using WebLogic 11G, and despite my efforts, our customer is not eager to switch to newer versions, so we are still on Java 6.
Oh my goodness. No, you have to tell them. You have to tell them what is it that they're investing in. What they are investing in a Java EE application is greater productivity. So there's leaps and bounds improvements. Just show them, I have a slide deck on my public SlideShare account on Java E7 and on Java E8. Each of those slide decks is almost 50 decks long. You saw how difficult it was for me to stay within a time frame to explain to you what is in Java 8. Show them these slide decks and tell them, look, a basic overview of Java E7 and Java E it takes an hour to barely complete it. You are missing out on all these features by staying so behind.
Thank you.
I have a question about, should I buy a license to use Java EE 8 in production, or it's not necessary now?
That is entirely up to you. I have lots of customers that use Java EE applications without paying the vendor a single dime. So a lot of these people are using Glassfish or using Wildfly. I do have a lot of customers that do pay commercial licenses. So they are on, for example, something like WebSphere Liberty. It is an individual choice. I'm not going to tell you one way or the other. I will tell you that I tell my customers, please pay for the platform you're using. Okay.